So exercise momentum, the MCQs and first three questions actually I have recorded, so I have already shared with you. So we'll begin with question 4 onward. If you have doubt, you can let me know. Question 4. Any doubt in question 4? This is an exercise related to momentum. Question 4. Anyone having a doubt or a question? Question 5.
Teacher, I have a doubt on the velocity. Like, how do we
Okay,
calculate the velocity?
sure. Okay, in this question, I will solve first part 1, 2, and 3. Look in the question, part B. Show figure 3.1 shows a collision between the two blocks A and B on a smooth horizontal surface. So two blocks are there on a smooth horizontal surface. Before the collision, the block A was having a mass of 2.4 kilogram and it's moving with a velocity of 3. And block B has a mass of 1.2 and it is stationary, not moving. After the collision, the block A and block B stick together. So when two objects stick together, they will have the same speed. First, we need a momentum before the collision because A has a mass of 2.4 and it has a velocity of 3. So 2.4 multiplied by 3, what we'll get? We'll get 7.2 kilogram meters per second. Then the second part is velocity. Whenever you see a question related to finding a velocity in the momentum, then what we do? We use a conservation of the momentum that the momentum before is equals to momentum after. So the total momentum before is equals to total momentum after. So what is the momentum before here? That is 2.4 times the velocity, that is 3. So 2.4 multiplied by 3, that is the momentum before
Sir,
for
the velocity always remains constant.
which one?
The
Before?
3.0 meter per second is always constant.
Yeah, because the object is not accelerating before the collision, so yes, we will take as a constant.
Okay.
And this object is stationary, so it's not moving. So what is the momentum? It is a mass and multiplied by velocity. So its momentum will be 0. The mass of A is 2.4 and the mass of B is 1.2. And they mentioned both objects stick together and they move like stick together. So when two objects stick together, it means they will move with the same speed. So it will be 2.4 times V and 1.2 times V, the momentum. Because momentum is the product of mass into velocity. When we simplify 2.4 times 3, so it will be 7.2. This will be 0 because 1.2 times 0, so that will be 0. This will be 2.4V plus 1.2V, so that's equals to 3.6V. So 3.6V, it's 3.6 is multiplied, other side will be divided, so 7.2 divided by 3.6. So 7.2 divided by 3.6, so we got 2 meters per second. That is the velocity at which these two objects, when they stick together, they will move. Is it clear?
Yes, teacher. And what about the impulse experienced by
How
block
to,
B?
yeah, how to work out the impulse? Impulse means the change in momentum. The final momentum minus initial momentum. But we need only for B. So what is the final momentum of the B? The mass of a B is 1.2 and V already we worked out, which is 2. So what is the final momentum? If we need the impulse of the B, it's a final momentum which is 2 multiplied by 1.2 minus the initial momentum. B was stationary. So it will be at rest. So initial momentum is 0. So when we 2 times 1.2, so what we got? We got 2.4 and the unit Newton second. That's the impulse of B. Is it clear? So when you're finding the impulse, you just take that object and its velocity before and after and take a difference in the momentum before and after, you will get the impulse of the object. Is it clear?
Yes.
Then suggest why the total kinetic energy of the block A and block B after the collision is less than. So look, if the energy before and after is not same, what does it mean? It means some of the energy might be lost in other forms. So that is, you just have to refer, like energy might lost in the form of heat or sound. That's why the total kinetic energy before is not equals to total kinetic energy after the collision. So it's related to energy concept, that energy is lost. Question 6, any doubt? Question 6. No doubt? Yes, Hamad, Anas, Abdullah. Yes, Abdullah.
So in 6A, can we write instead of the symbol for momentum, can we write momentum equals to mv?
Actually, it's said a word equation. So in a word equation, you are supposed to say that momentum equals to mass times velocity. Like if you write here P is equals to mv, you will not get the mark. Why? Because it's clearly mentioned that word equation. So in a word equation, I should refer that I should say momentum equals mass times the velocity. So if I use any symbols, you will lose the mark. So it's supposed to say, write the words. Question 7, any doubt? Question 7, any part? A, B?
Sir, I have in question number 7, part 1.
Okay. So in question 7, state the expression for a kinetic energy of an object mass m moving with the velocity v. So what is the expression for the kinetic energy? The kinetic energy is half mv square. That's the expression for the kinetic energy. So actually we just have to look, read the question properly. Here it is written expression. So in expression, I don't have to write like ke is equals to half mv square, because if I use equal to, that is not called expression, that is equation. So in an equation, there must be equal to. In expression, you are not having left and right hand side. You just write the value. So you are just supposed to say half mv square. But in the previous question, in which they asked us write the equation, word equation, that's why when I wrote that momentum equal mass times the velocity. So if I write mass times the velocity, I will lose the mark. Why? Because the word equation is there. So in equation, you should like write equal to. But in expression, you're not supposed to write the equal to. You just write the, so you just mention half mv square. Then state and explain whether kinetic energy is a scalar or vector. Any form of energy, even it's elastic strain, nuclear heat, thermal waves, all forms of energies are scalar quantities. Should I solve part B? Any doubt in B?
Yes, sir. You should. I just wanna maybe solve
Okay.
it.
In the first part, they mention here that we have a stationary car, and there's a car without passenger. The empty car is there, which is stationary as well in the beginning, and there's a car which is moving. After the collision, the empty car moves forward with a direction in the same direction with a speed of 4 meters per second. For the passenger car, we have to first determine the momentum. How to determine the momentum? The mass of the passenger car is 200 and its velocity is 2.5. So to get the momentum, it will be 200 times 2.5. So what we'll get? We'll get 500 kilogram meters per second. That is the momentum when it is traveling at a speed of 2.5. The next part is the speed and the direction. Remember my words that whenever you see a question related to momentum and they ask us to find the speed and the direction, so what we should do? We should use the conservation of the momentum. What is the conservation of the momentum? According to conservation of the momentum, the total momentum before is equals to total momentum after. So what is the total momentum before? The mass is 200 and the velocity is 2.5. So 200 times 2.5.
500
Plus,
kg meter.
yeah, that will be 500. And this will be, this mass is 50. but this is not moving, so we'll write as 0. That is the momentum before. What is the momentum after? If you read the question dimension, this car, the empty car, move with a speed of 4 meters per second. And the stationary car, we don't know what speed it is moving, so we call that as a x. So the momentum after the collision, that is 200 times x, or you can also say v, so if you call v, so 200 times v plus the mass of the stationary car is 50, and what speed it is moving at a speed of 4. Now, when we simplify this, 200 times 2.5, so that's equals to 500. 50 times 0, so that is equals to 0. 200 V and 50 times 4, so that is 200. This 200 is added, other side subtracted. So it will be 500 minus 200 is equals to 200 V. So 500 minus 200 is 300. So 300 is equals to 200 V. We need the V. So 200 is multiplied, other side will be divided. So 300 divided by 200, what we'll get? We'll get 1.5. So we got 1.5 meters per second. That's the speed at which this car will move. And which direction it will move, because we got a positive answer. So it means it will move in the same direction as the original. If we get a negative answer, it means it will move in opposite direction. So when we simplify and I got a negative answer for the velocity, it means the object bounced back or the object is moving in opposite direction as the original one. But if we get a positive value, it means the object is moving in the same direction. How we know it? What is multiplied? Yes, Abdullah. Which one is you're asking?
I'm talking about 200V, like.
Because the total momentum before is equals to total momentum after. So this is a mass multiplied by velocity. That's a momentum first object. Then the mass multiplied by velocity, that's a momentum of second object before collision. After collision, the mass is 200 and the velocity is unknown. So mass multiplied by velocity. Because the momentum is always a product of mass times the velocity. That's why. So it's a part of the formula in which the total momentum before equals to total momentum after.
Sure.
Is it clear?
Yes, clear.
So the direction, it will be same as the original, or you can also say it's moving towards the left-hand direction, left-hand side. Then they ask when the fix to the front and the back end of a car are large springs. When the car collide, the spring compress. The total energy of the car after collision is equals to total energy before. Describe the energy transfer. So what will the energy transfer will take place? Look, when the springs, these springs, you can see when they will compress. First, the car is moving. So which form of energy it will have? Kinetic. But when the car collides, the spring compress. So which form of energy? When object deformed, stretch or
Elastic.
compress. Good. So the kinetic energy will transform into elastic strain energy. And then the car moves back again. So if the car moves back again, so it means which form of energy again? Again, they will have the kinetic energy. So what is the energy transformation here? The kinetic energy for transform into elastic strain energy when the spring compress. And then it again transform back to kinetic energy when the car starts to move. Question 8, any doubt?
No, sir.
Any doubt? No doubt? Question 8, okay. Question 9, any doubt?
No.
Anyone having a doubt or a question? No? Question 10, any doubt? Question
So
10.
what's the answer for question 9, part 2?
Average force. I will solve this.
Yes.
Look, the mass of a ball is 4 kilograms. The girl exerts a force on a ball for 0.6 seconds. The speed of a ball increases from 0 to 12 and before it leaves the hand. Momentum of a ball as it leaves the hand. Momentum is a product of mass and velocity. So mass is 4 and the velocity is 12. So 4 multiplied by 12 will get 48 you can say kilogram meters per second. Then the average force. Average force, we know because this question related to momentum. So we have the formula that impulse is force multiplied by time. So impulse is a change in momentum. So if I need the force will be equals to impulse divided by time. I can use this formula, I'll get the answer. Or there's also another formula, I can also use F is equals to ma. Force is mass times the acceleration. I'll get the same answer. I'll solve with both, but I'll get the same answer. Even if I use F equals ma or I use impulse divided by time will is equals to the force. So if I use F is equals to ma, the mass is 4. What about the acceleration? It's a change in velocity divided by time. So it will be 12 minus 0 divided by time, which is 0.6. So 12 minus 0 is 12. So 4 multiplied by 12 divided by 0.6. What's the answer? 4 into 12 is 400 and 4 into 12 is 48 divided by 0.6. So it will be 480 divided by 6. 480 divided by 6 will
80
be
Newton.
80 newtons. Yeah. So this will be 80 Newton. I can also use this formula that impulse divided by time. Force is also, the change in momentum is, yes, Abdullah.
I had a question that the momentum would be considered as change impulse, yeah?
Yeah, when the object, if an object starts from rest or an object stop, then the change in the momentum is same as the momentum because one of the value is 0. So in this case, the object start from rest. So as the object starts from rest, it means this will be 0. So it means the momentum divided by time. So it will be mass 4, the velocity 12, and the time is 0.6. Again, I'll get the same answer. So remember that whenever the object starts from rest, the object is stationary and it moves, then the change in momentum is same as the momentum. Or if a moving object is there and it stops, then in that case also the change in momentum is same as the original momentum. So it is only valid if the object is stationary at the beginning or the object stop after some time. Question 10, any doubt? Question 11, any doubt? 11A, B. Any doubt
Sir,
in
are
this?
you in 11B?
Okay. In the question, the ball of a mass 0.4. In the question, the ball has a mass of 0.04 kilogram. The golf club is in contact for 5 exponent minus 4 second, and the ball leaves at a speed of 65. The momentum of a ball as it leaves the golf club. So we need the momentum, which is a product of mass into velocity. So mass is 0.046 and the velocity is 65. What's the answer here when you multiply them? 0.046 times 65.
2.99 kg meter per second.
So 2.99 kilogram meters per second. Then we need the average force. As I mentioned again here, that the object, if you see the ball of it was there in like it leave initially what was the ball was stationary. So it means if I need the force is also impulse divided by time. But when the object starts from rest or object stop, then the impulse is same as the momentum. So that is 2.99 is a momentum and divided by the time interval, which was 5 exponent
Sir,
minus.
for
Yes.
part 1, I rounded it off to 2.1 kilogram meter per second.
It was 2.1 or 2.99?
It was 2.99, but then I rounded it off.
So you wrote 3. 2.99 should be 3.
Oh, okay. Oh, okay. Never mind. Yeah,
0.
you're right.
0.046 times 65, that is 2 so approximately 3. And then we have like 2.99 or 3 divided by 5 exponent minus 4 or 0.0005. So it will be equals to 5,980 Newton. Is it clear? So remember that whenever the object starts from rest or object stop, the impulse is same as the momentum because one of the momentum is 0. While the golf club is in contact, the ball become compressed and change the shape. So whenever object changes the shape or compress, which form of energy, state the type of energy stored. So we'll say elastic strain energy will be stored in the ball. Is it clear?